Hello, everyone. Thanks to be here. I'm glad to do this talk this morning. I hope you're not too tired from the two previous days. So I'm Henri Tremblay. I'm working for Software AG, Terracotta, mainly on EHCache. I'm mostly developing open source EHCache, but also some enterprise layer underneath. I'm Java champion because of things I did when I was young. So a framework named EasyMock, so base of most class mocking in this world. And I'm also Jug leader at the Montreal Java user group, so if you want to pass by, just come say hello. I'm Oracle Groundbreaker ambassador as well. And since last week, I became what used to be called a Java 1 Rockstar, which is now Oracle Code Star, which means I gave a great talk last year. I hope it will be the same this year, so please do vote for me. And we should have a good fun for the 2 hours. The agenda today is to, of course, talk about Java. We'll go through Java 5 until 11. The idea is to showcase some stuff that I think people have missed in Java 5, 6, 7, 8-ish, and then start talking about what's happening in 8, 9, 11, because I don't think you've been there yet. I'll take a vote for that. So who's currently coding in Java 8 all days with lambdas and using the real feature? Okay, that's pretty good, actually. Who's not? Some people, okay. So don't worry, we'll give a quick overview of 8 to put everybody on par. Who's above that? So 9, is there any 9 here? Some 9s, 10, 11, okay. So that's pretty much what I expected. Good, the talk will be accurate and correct. I'll take 5-minute breaks because I don't think your attention span is 2 hours long, so we'll take a 5-minute in the middle at any point I feel like, and we'll resume. So please do come back after the break, and please do come back on time because I will start on time, so it's nice for everyone. This we just do. This I said, don't forget, it was for me. If you have any questions, it's a 2-hour talk, so just ask them. I'll cope with that, and we'll. If the question has a too long answer, I'll process it after the talk. If it's all right, I just answer it here, because if you get lost in 2 hours, you'll get lost for a long time. So no point in doing that. Okay. All good? Yes? First step, I will talk a bit about the Java delivery process, because as you might have noticed, it has changed since Java 9, and even for Java 11, we're getting in some new world I will explain about. So before Java 9, we used to have a version whenever. So Java 6 took a long time, so it stayed for a long time because that's the moment where Oracle took over Sun. So it stuck there for 5 years. It was replaced. Then Oracle decided that they would deliver a new version of Java every 2 years. In fact, they were late, so it was more 3 years. But at least it was like reliably appearing. Problem with that is that new feature takes 3 years to appear, which is not really a good thing. However, we are pretty happy with that because migrating was easy. When you have to migrate your framework, you have 3 years to migrate it slowly. When you're an application in production, you can migrate as well as at your own pace because you have 3 years to do so. This good old world that was comfortable but featureless is gone. We are now in a 6-month delivery system, so Java 9 has appeared, is alive was alive actually for 6 months. So now Java 9 free version from Oracle is unsupported. Java 10 died as well in September, and Java 11 is currently the only supported version apart from 8, because 8 is special. But starting from 9, Java 11 is the only current free supported version of an Oracle JDK build, and that's the complicated. So, as you can see, before that, version tend to overlap a little bit. It won't happen anymore, so you will get a new version every 6 months, and it will supersede the previous version. Java 11 is special because it's flag LTS, but if you're using the free Oracle JDK build, which is only valid 6 months, it doesn't mean anything for you. So LTS is just to say if you pay Oracle for support, we will support 11 a lot more than the other version. So 9 and 11 are currently unsupported unless you go and some extended plan, but 11 is normally supported and will be until the next version, the next LTS, which will occur in 3 years. Other vendors might support intermediate version or different version. We don't know. I'll try to summarize that. If you highly suggest, so there's a link here. I will also give it back at the end. It's all the Java champion wrote a really long paper explaining how all this is working. We looked with Azul, Red Hat, IBM, of course with Oracle, and we sorted out everything we could understood from the new process, and it's all written in there. So please do read it. It's extremely important to know if to let you know if you're first legally allowed to use the Java version you're currently using. Second, to know if you're supported or if you should get support somewhere. So first thing is there's the Oracle JDK. Oracle JDK is built by Oracle and is available on their website. It's free for 6 months to be used by anyone. After that, it becomes, you need to pay support to keep using it. Be aware of that. And they will support it and they will provide patches for these 6 months. Then there's another build called the OpenJDK build, which is the exact same thing. So OpenJDK and Oracle build, the hotspot one, they used to be different. They managed to make it absolutely identical. It's just that it's built by 2 different instances, let's say. It's like 99.9% identical, and the little tiny bits that are not, you don't care about them. The Oracle JDK is built by an organization, so I think it's an NGO actually. It's called Adopt OpenJDK. So they will do build for every versions, and but they won't give any paid support. So they won't support anything. They just give a build. It's free forever. Use it as you want in any version, but they won't support. And then, of course, you get other vendors like Azul with Zulu and IBM with J9, Red Hat with their Red Hat Linux embedding Java in there, and these and some others. These might support whatever they feel like. You will see in the document that there's a lot of may and possibly there. It's because there's some doors open. So let's say we have, I don't know, a Java 9 build that it's gone right now, but we discovered that there was a really used security flaw in there. Oracle may decide to patch it, for instance. So they have left the door open that, okay, for stuff we might something, but it's on the best effort case. We might not do anything and just leave it like that and tell you to just migrate to the latest one. So, so that's how it goes. Any question about that? Good. Your best bet in production is probably to get support or to use OpenJDK if you want something clear, because otherwise you need to migrate all the time. We almost changed the name of Java, so the versioning name of Java. So for a little while, we were supposed to start calling it a bit like Ubuntu version, so 17.9, 18.3, to give the month March and September, so the 2 release dates, and the year at first. Everybody yelled at that, partly because we're used to our cool old numbering. The other thing is that pretty much every framework is doing parsing of dates, and this was breaking everything, and it was super annoying. So after a big discussion for this main basic but really important reason, we decided that we'll stick with the normal Java version, so 9, 10, 11, 12. But you will see appear, if you do Java dash version, you will see appear a vendor version which will move according to time. So, and that's also helpful because you know the year and you know the month at which the bill went out. So this one was early access 11, so it's it's an 18.9 version, and so don't be surprised if you see that. It's normal. The funny part is that at one moment both will reach each other. So it will happen in September 2025. The Java version will be Java 25, and the vendor version will be 25.9. So I don't know what will happen at that moment. The herd might implode, or or we'll start using the new scheme. I'm not exactly sure. So we'll see there. But you can realize from that. So the next version, the next LTS is 17. Then 23, so every 3 years. Things are going really fast. The way it goes is that they develop features. If it's ready, it goes in. If it's not, it just waits for the next 6 months. So it's really a different train. It's more a continuous delivery process than what used to be. That's why the previous version were late, because every time they were doing a roadmap at the beginning, okay, this should take about 2 years to develop, and then they just realized that it wasn't totally ready. But they kept the feature set, and now they're not keeping the feature set anymore. They're just developing features, and they go in one after the other. Okay, the last thing about that is that deprecated is back. So as you might be aware of, before Java 8, nothing was deprecated since, I think, Java 1.2. And so we stopped deprecation entirely. And before that, everything that was deprecated stayed there forever anyway. So you have deprecated thing like the date class, for instance, most of it is deprecated, but it's still there. That has changed. So starting with Java 9, they started to re-deprecate stuff heavily and remove stuff as well. And the interesting part is for Java 9, you get 2 new fields on the deprecated annotation. So one is since, so that's saying this was deprecated since Java 1.2. And for removal means in the next version it will probably be gone. So if you're using that, beware and move away, please. You can use that in your own frameworks. So I really like these two fields. It's fairly useful to help your user know how it's going. And if you see anything deprecated starting with Java 9, go read what's happening there. And if it's for removal, please go away because it will disappear. It has happened. You will see in Java 11. In Java 11, a lot of things, since it's LTS, they try to remove as much thing as possible because they have to support it for a long time. So they kicked out pretty much everything that should not have been there ever. Cool. So that's for the delivery process. Now let's talk about Java version. I'm cheating a bit. We'll start with Java 1.1 because there's something I want to talk about in this version, and it appeared there because Java 1.1 was the version of anonymous inner classes. Who was there, like doing Java? A bunch of you. Not bad. Good. So for those who were there, it was a great moment because it allows us to do a lot of cool things, actually. This is 97. And one of these things is this terrible mustache instantiation. So you might see that even in conferences because people like to use it. It's quick to instantiate stuff. But it's actually a terrible thing if you overuse it in your code. So it does work. It creates an anonymous inner class, and and then it initializes all the fields, and it's a bit shorter than what you would normally do by putting in the fields right under. But it does create an anonymous inner class. So if you go crazy about that, you will create tons of anonymous inner class. You get a bloated jar at the end, and you're just calling for inefficiency, actually. So it's fun for a little, but in normal code, it won't save you that much, and it's just terribly ugly. So that was the 1.1 version. So you see no generic, and I'm using hash table. This is the modern one. So there's a diamond operator, and it's all nicely typed, but it's the same thing. You still get a terrible anonymous inner class, and don't do that. In Java 9, it got better, because we now have immutable maps or immutable collection classes. So this one is a map of, but you also get a set of, list of, and whatever of. There's only one key value, so it looks a bit like collections.singleton map, but it's not. I could put value key 2, key 3, key 4. I can put as long as I want on the right side. For like to make it fit in the slide, there's just one field, but we can put many values. So this is really, really nice, and I used to have libraries. Gueva was doing that, or I used to call my own to be able to do that because it just makes your life easier. The only thing to be aware about that is that it's immutable. So whatever you created here won't be able to be modified afterwards. You won't be able to add fields, remove fields. In general, that's what you want, because when you hard code some array, or map or whatever, and you will generally put it in final somewhere and never touch it ever again. So it should be fine. If you really do want to have something that is modifiable, you can create your own tooling or your own helper class, or the quickest you can do is this. It will remove the anonymous inner class, but will add a map dot everywhere. It's not that bad, and I don't think it will change your life and put your project late if you do that, and it's much cleaner. For those who don't know about the braces here, the way it works is that when a class is created, instantiated, you get fields 1, fields 2, fields 3 get instantiated if there's something assigned to them. And then if there's a block like that, the block is processed, and then it goes down the other fields. And then the constructor will be called. So fields, these blocks, constructors, so you can play around. But of course, you could put that in a constructor. It will do the exact same thing. It's just if you want to keep it close to your map. Doesn't matter. OK. Still good? All waked up? Yes? Great. Java 5. Sorry. Java 5 is a really big version, obviously. That's the version where annotations were added, generics were added, enum types were added, static imports were added. So lot of stuff in there. I think it's the biggest Java version ever. Second one after that was probably Java 8, followed by Java 9, but doesn't really matter to do contest about that. But it's huge. And I will say only one thing about it, because there's something that is fairly unknown, and so I like to tell people about that thing. It's called type witness. Who knows what is a type witness? No one. Wow. I could do conference only on that. So type witness is this. So you see the syntax. So you have a class or an instance, dot, and then you add some typing there. It's not that clear, so I will code it for you. So the idea behind this is that, not the right keyboard layout. Here we go. So here's an example. I have any object here. Any object is returning t. So the way the compiler works is that t will be inferred to whatever it is assigned to. In general, that works because there's no ambiguities. If there's one, it will just tell you that no, I cannot pick randomly because there's a list and a set here, so I don't know what to choose here. So when you hit that kind of problem, there's two solutions. One is to tell, OK, but it's actually a list of string that I want, so just cast it into that, please. That will work. It will compile. However, you will still get an unchecked cast, which is extremely, extremely, extremely annoying. That's because if I was casting to not a generic type, it will work perfectly. But since I'm casting into a generic type, and you get what we call erasure, so at runtime the type will magically disappear, the compiler cannot guarantee that this thing will work at runtime because the cast might be a list of integer casted into a list of string, and at runtime it will just pass. So it still gives you a warning. So there's, of course, if I remove the generic, it's not better because in that case you'll get a raw type error, obviously. Which means there's only one solution, is to use the type witness. So after today, you will be able to solve these kind of problems. So the idea is to do this here. Which is, you just tell the compiler what is t. You give it the type. So instead of letting him infer and guess, you tell him, OK, I want t to be a list of string. Just deal with that. So try to make it fit somewhere. If it fits, you're good. If it doesn't, just yell at me, please. So, of course, if I change it to something else, like string, it will say, hey, there's no foo taking a string in parameter, so I don't like that, so I don't want to compile. But if it sees list of string, it's, okay, you're saying it's a list of string, I trust you, I keep that, and I'll find out if I can pass the result to something accepting a list of string. Is the case, so it works perfectly. And of course, if I recompile again, you will see that there's, you don't see it because it's successful, but there's no error. I was expecting a bit of successful at the bottom, but it disappeared, it seems. But yeah, it's perfectly working. It's not, you won't use that every 3 seconds, but you will. In Java 8, you will a bit more because when you do like functional programming, you go down, and at some point, it's highly possible that the compiler gets lost and will undertype stuff or won't guess the type you would like. So you can add this to make it happen as you would like to. So keep that in mind. Instead of casting when it doesn't work, just add the type witness. Try, please, to avoid to suppress warnings all over the place before trying to use it. Cool. So that was for Java 5. Let's go to the next version. Java 6. 2006, this is the last version from Sun Microsystem. It actually brought pretty much nothing for developers. It's a bit of a sad version because it's an unloved version. There was a lot of cool thing under the hood. So a lot of performance improvement, and you could swap 5 and 6 together, and you get like just increasingly faster things. So it was an awesome version under the hood, but nobody knew about it because when you just use it, it seems exactly the same as before. But it still was a really useful version. But there's nothing to tell you about, it's just faster. So let's go to Java 7. So Java 7 is 2011. That's the first version for Oracle. I told previously that it took a lot of years to get out because it was pretty messy to decide what will be there. In the end, it was a pretty praised version because there was a lot of syntactic sugar in there. And there was also invoke dynamic, which is a dynamic call to something. You don't care about it, but for like language developers doing alternative language, like so non-Java, like Scala, Groovy, or whatever, that was really important because it brought a lot of performance to them. And it's also a thing that is allowing lambdas to work correctly, and a lot of new development in 8, 9, 11 are using invoke dynamics. So invoke dynamics is something, it's a code instruction, so it's heavily under the hood, but it's super useful. But for our point of view, there's a lot of cool syntactic sugar, so I'll just summarize them, and I'll have you vote as well to know if everybody knows about them. So you can do switch on strings. Who knows about that? That's getting bad. 50%, not bad. Who doesn't know about it? Okay, the others, everybody else is just not voting, or you don't want to tell you don't know about it. I don't know. So I'll assume everybody knows about that. And this is really just syntactic sugar. So if you take the final byte code and you look at it, it's you will see if on hash codes, on string hash codes, and then a bunch of ifs to make sure it's the actual correct string, because 2 strings can have the same hash code. So it's really compiler sugar. It's not going anywhere into the bytecode. And it's way more complicated than you would think to implement. So cool. Next tiny thing is the diamond operator. I still see some people not using it all the time, so stop. It's just make your life terrible. It makes the code so much shorter, and typing on the right side doesn't help anything. Everybody knows what it is. You just read the other side. So please do use that. It's even a good thing to just refactor your code using IntelliJ or Eclipse to tell it, hey, please just put diamond operator everywhere you can, because it will shrink your code, it makes it more readable, and it's highly useful. So do use it if you can. And there's nothing more about that. So diamond operator. You can use binary types. I've never used it ever, and you can get, but it's there, so sometimes more readable than using hexadecimal to represent something. I do like the underscore. It's not harmful, it's cute, and it makes things more readable. So you can put underscores between numbers. There's nothing enforcing you to put underscores every 3 zeros. You can put them wherever you want, but then nobody will be able to read that correctly. But it does work. Ooh. Much more important, multiple catches. As you might have seen, I'll vote again. Who knows about that thing? Who used that? It's getting well known, so I'll go fast on that. So before, we used to do this terrible 2 things here that was repeating code because we had to catch all the catchable exception and there was no way to put them all together. Now we can, so we can pipe them and then just log the error. The cool thing about it as well is that it will look for the best denominator, let's say. So that's a bad example for that, but if let's say you have a business exception and you have 2 exceptions extending that, everything available on business exception will be available. So yeah, if you have an error code on business exception, you'll be able to do get error code. So it will infer whatever can be used on the exception from the most common type, which in general will be exception, but in some cases will be something a bit lower. So use that, that's cool. And use that even more. This is the auto-closable one. It's the thing that will magically close a stream for you. So before we used to do, we create a stream, then we do stuff with the stream, and then finally we close the stream, and in general we ignore the closing exception because it's not good practice to throw something in finally, and anyway we don't know what to do about it. So the auto-closable, who knows about auto-closable? Okay, that is getting well known, but I have a part on that, so you'll learn something on this one. So as you see, there's a try, and you put the stream there, and it will close it by magic afterwards. The fun part is that we normally do the before like this. My laser pointer just doesn't show anywhere, I think, but it doesn't matter. So in the before part here, but actually what you should code is that. So what you should code is to close at the end of the try, then catch the exception, and close in the catch. So you have 2 different close. And if you catch an IO exception during the close, you add it as a suppress exception of the original exception to throw that to keep the information needed. And nobody ever does that. But auto-closable will for you. So if you use auto-closable, you get the benefit of having all the correct suppress exception at the right place. And if you have what we usually have, like an input stream and an output stream, you can put them in the same try, and all the close and the finally needed and the suppress will be correctly added for you. It's a lot of work to do manually, and it's just magic. So do use that, because it does more than you will do because you're not that motivated in general. Cool. There's other things there. They have added some fun things about file I/O. So there's a files class, there's a path class, and a files class. Have a look. So if you want to read a file before trying to do the normal loop, reading lines and playing with them, just go there and you probably will see what you need, actually. So try not to do the normal iteration anymore. There's a lot of cool stuff as well, file lock, symbolic link, so things. If you're a desktop application, you might heavily need to do these things. Cool. That's all for. Just a second, please. I'm a bit of a flu. That's why my voice is not that working well. So Java 8 was out in 2014. So it's getting old, but it's not that old. So we're now in normal realm. Of course, there was lambdas in theirs, but you get also different things that makes lambda works, like default methods, static methods. Little things change. You get Nashorn that replaces Rhino for JavaScript, but don't use it because it gets deprecated in Java 11 anyway. Um, these things happen. The new date API, JavaFX gets JavaFX gets added in Java 8 for real, but it's removed in Java 11, so use it, but separately. Completable feature, I will talk a little bit about that. So let's get started. First fun, this is just a quick smiley. We used to use a sun miss base 64 to do base 64, or use Commons Lang, I think, to do base 64. So they finally, after 20 years, they've added a real public base 64 class. So if you want to do base 64 encoding, you do now have what you wanted for ages. So it's there. Just use it. But more interesting things are, of course, the datetime API. So starting now, you should not ever again use a date, a Gregorian calendar, a whatever calendar, or any of these things. Don't. Just don't. The datetime API is much better. It comes from JodaTime, so for those using JodaTime, it's the same guy, so Stephen Colborn, who did that, with slight refactoring, but if you're used to JodaTime, you'll feel in a safe place. It's immutable. A date is a date. There's no hour blended with dates. So date is date, time is a time. You can offset, so it's managing zoning all correctly and just a breeze to use. There's an example here. So here I'm getting local date time now. Then I'm shifting to the first day of the month. Then I'm zoning it in Europe. I'm adding 5 days to be on the 5th of the month. And then I'm formatting it. That's the same date format, simple date format. Don't use that ever again. This one is thread safe. That's cool. And it works. So, and it prints the date at the moment I did that. If you try to do that with the Gregorian calendar, it's probably 500 lines of code. So it's really nice to use. Who used that? Not bad. I should check if it's always the same who raise their hands or not. Okay, so that was for local date time. Now a bit of Lambda. I'll do a little introduction for those who haven't looked at it at all, but it will be really quick. I'll more be talking about cool features that you can do with that. So it comes from mats. So if you wonder where the name is coming from, it comes from mats. It means that thing, which is actually can be summarized into a lambda is a method with no name, or a function, to be precise, a function with no name. So above here, you have a square of sum. It has a name because it's a square of sum. And underneath, you have the exact same thing without a name. So lambda is a function without a name. And that's it. So in Java, you will do functional programming by using lambdas and named function, like in this example. So I have a collection for each, and I want to apply my lambda, which does a power, which is a name function of each A and B to do the calculation. So, and yes? You're right. Yeah, you're right. Yes, wrong. I've refactored it a tiny bit, and so yes, it should not be reassigned to C. It should be in place. You're absolutely right. Damn it. Okay. So the syntax goes like that. The first one is so it's an arrow all the time. You have the argument, which is E. Then you use E, and E, the type of E will be inferred by whatever the context is. So in general, the type of the list, of course. Then you can type it if you want. It's used less most of the time, and it's longer, but it's a bit like the type witness. In some cases, it will help. So you could put a type. Also, if you think your reader is totally lost and has no clue what your type is, you could type it to help him, or you could just refactor because it's probably that your functional programming sequence gets crazy and nobody can follow it. But so you can type if you need to. There's a multi-line version Of course, you can put as many arguments. So the original one with one argument has no parenthesis. If you start adding more than one argument, you just add the parenthesis and you put your different elements. If you start typing, you need to type each of them. It's impossible to just type one in the list of arguments. So there's the multi-line. As you might have noticed, above, there's no return required, there's no semicolon required. As soon as you add braces, curly braces, you need to add a return. I don't need because it's a println here, but if I was returning something, I would add a return. The semicolon is there, and I could add as many lines as I wanted there. The pitfall here is don't do that. So a multi-line is fun if you have maybe 3 lines, but after 3 lines, just refactor that in a method reference. I would show that right after, or whatever method you want to use. Because the problem is with the lambda, it's a function without a name. So the only way to know what it's doing is to read the content of it. You need to read the code to know what it's doing. So if you're doing something freakishly long, the person reading you will have to read a freakishly long amount of code to be able to know what it's actually doing. So watch out with that. The last one is a closure. So it's the same thing, but it magically uses greeting. It's important because the implementation becomes really different underneath. So this one will capture greeting and will keep it in the final implementation of the lambda. The others do not need to do that because they're self-sufficient. So, but this one, it's a bit like in JavaScript, we tend to capture stuff. That's the same thing. It will capture the value and put it somewhere else. It also means that it's the same as for anonymous inner class. Everything that is captured like that should be final. But in Java 8, they decided that everything was implicitly final if needed. So you don't need to put the final flag anymore, finally, because it was just painful and useless. So it will just consider that it is final. Of course, if you try to modify it, the compiler will yell at you telling, hey, this is implicitly final, please don't modify it. Okay, where are we? Good. That's it. So next, to be able to do all the functional programming things, they were required to add a lot of methods to the collection API. But as you might be aware of, if you add methods to an interface, you need to implement them, which is not that backward compatible, and it's pretty annoying. So they invented 2 cool things. The main one is the default methods. Who knows about default methods? Oh, okay. You're good at Java 8, actually. So default methods have a default implementation that you can override in the concrete class afterwards. It's heavily useful to implement things that can reuse other methods that are already existing in the interface. Here, what did I do? So an example is here. I have a replace all, and it's a default, and the implementation will use the replace. It will just iterate and do a replace of all the elements, and so I can implement it with something else. So I don't need to really force the person implementing it to do so, but they will in some cases because they want to. A good example for that is for EHCache, we have something called a loader writer. So a loader writer will let you load things from the cache, for instance. And there's a load and a load all. And when we migrated to Java 8, load all became a default method because I can just iterate on the values and do load, and that works perfectly. However, if you want something a bit more transactional and put a database transaction, for instance, around that, you would prefer to implement your own load all, but it does work by itself. It's just possibly not what you want, but it works. So it's just less painful for anybody who's implementing your code. So bottom line is, do use it. Like if you if you add something on an interface, think about, can I implement the default behavior on that will makes most people happy or not? If it's the case, just do it, and it will save pain for any of your implementer. Static methods appear, they're mostly used for factories, so you get, or for special values. There's one like, that's a real example. So on in-stream, you get empty. If you want an empty in-stream, you just do in-stream.empty, it will return it to you. And this is a static method on interface. It removes the needs to have everything we used to have, like files, path, and here it will be, for this one, it will be, I don't know, in-streams, in-stream helper, something like that. So it will remove all the factories and helper we used to have. So it's pretty neat. Of course, it's because it's kind of self-contained. So if your factory might get extended at some point, don't do it, because you've kind of hard-coded the result in the interface. But if the plan is to return normal thing like empty will ever be like that. It will be empty. So you could code it directly in your stream instead of adding a helper class aside, which is just annoying. And it's harder for people to find it, actually. Okay, something you probably don't know. I've discovered that like 3 weeks ago. We're preparing this conference, and I never thought about it, actually. So the interesting part is the new object part. Whoever did that? I'm getting back to an unknown realm. So the trick here is that I'm able to, and I will show you in code, actually. So I'm mapping to a new object, and then I'm adding fields in the new object. So it's creating an anonymous inner class. It's, again, a mustache kind of thing. So each time you do it, you get a new anonymous inner class. I'm BAs about this one. I do hate the anonymous inner class creation, but the result is really super cool, because since we don't have any tuple in Java, there's no other way to do it in a typed way. Let me show you. Let's start here. No, that's not it. That's not what I want. That's not what I want. What's that? 8. And that's something else. I forgot that one. Yes, we'll talk about that after. Okay. And that's not what I need. I need this here. I think. Do I need this? Yes, I need this. Okay, here. I have a person. And I create a map of person. And then you can create the fields. What's magical is that the compiler will say, okay, you've created an anonymous inner class. It has no real type, so it's not really possible to type it correctly. And if I do try, because if I was trying to do whatever here, the only thing I could write is object, actually. So it's kind of impossible. But if you don't type it, the compiler would just say, hey, that's the type you just created, so I'm happy with that. I'll give a random unknown type to it. And I'll correctly compile. And as you can see, I can use the ID and name underneath, and it works perfectly. It sees them. So I really feel I'm coding JavaScript when I do that. And so it's super cool, but as I said, it's an anonymous inner class, so don't overuse it. But really, the alternative will be to do something terrible like new object array, and then put my two values in there, and then retrieving this and doing something like long and entry 0. So that's terrible. I do hope that the syntax will become a syntactic sugar in the next Java version at some point, because it feels really, really useful. And we'll have some kind of tuple using that, I hope. Meanwhile, the best you can do is the terrible array or this, actually. The other fun, I'll talk about, okay, yeah, I'll talk about that later. And I'll add something on top of that when we'll talk about var. So wait for it, that's in about an hour. But var is in a later version, so just keep that in mind. The other thing, okay, yes, that's. So method references, that's the last stuff, and you probably already know about that. It's what you should use most of the time when you need to try to use that as much as possible. And if you can't, use lambda, but this should be the favor in general. There's 4 flavors of it. The basic one is, where is it? I should have put them in order. So the static one is normally what people start using. So you have a static method on a class, and you use that, and the train is passed to the paint blue here. So for each element. Then the other one is the instance one. So you have a list of trains, and you want to call repair on each list of trains. Then there's the instance one, so the P inboard here. P is an instance of some other class, and inboard will take a train and parameter, so it will be applied again for each element in the train list. That's how the system out println is working as well. And the last one is the constructor one, which is a bit weirder. So here, so new can be a method reference. However, it could be any constructor. So whatever match the parameters will be the correct constructor. So here, new is just a supplier doing a supplier.get. So that's the default constructor, taking nothing, returning and returning something. However, if it wasn't a supplier taking a parameter in the create and it was a function, that could happen for ArrayList, for instance. If you pass ArrayList colon new to something that is a function in functions, it will call the constructor taking size and parameter. So watch out, because you're always typing new, but you really need to check the typing of where you are putting it to know which constructor will actually be called for real. So that's the only catch up in there. The other thing, and that was a bit of a surprise for me. So that's E. Please give me my class. Okay. Here we go. Is this here? So the IntelliJs will tell you something like that. It will tell you, hey, here you're using a lambda, but you could actually, please tell me that I can replace here. You could actually replace it to a method reference. Problem is that if I run that thing now, it works. It works perfectly, even though the S is null on top. However, if I replace it by a method reference and I run it again, this is because the method reference wants the instance you're referring to exist for real. So it should not be null. The lambda doesn't need that, because if you don't call the lambda, it will just doesn't care about it. It's in the lambda thing, so s.length would fail if you were calling it, but it won't by just creating it. Yes?
That has other ramifications too. If you have a mutable guy that you are doing a method reference on, then a method reference will capture, whereas a lambda will every time go check what the current value is.
Yes. Yes. True. So yes, and that's another thing. So the instance for a method reference, the instance is really important when you use an instance method reference, and it will be checked and it will be captured. It could possibly be captured, and that will stay afterwards. It might give a null right away. So when you do this kind of refactoring, have a slight look at what you're doing, because it's not as easy and magically working as IntelliJ will tell you so watch out. And I've been burned by this one, actually, so that's why I know. Yep. So that was the little trick for method reference. Okay, Java 9. Now we're in unknown realm, I guess. It came last year, but it's already over. But we'll still talk about it because there's modules, and modules are there So there's a lot of things going on there. They did a big cleanup. So JDK used to be a big spaghetti thing, and they cleaned it up. They did all nice modules, so now it's a tree of dependencies. You get fun things like there's an HTTP client, so if you want to do a really quick HTTP client to get some URL, there's a really useful one and usable one because it used to be pretty cumbersome to use. You got JShell if you're into that kind of thing. JCMD is slowly replacing JMapAt and all these J other things. Everything will go in there, so there's some added functionalities as well. G1 is the default. So you don't have the same garbage collector by default anymore. Watch out if you migrate. Please do some benchmarking to see if that's what you want. We saw before that there are immutable collection. There's a fun unknown things. They have unified the JVM login. If you're like me, and you tend to, for instance, debug, I don't know, the XML API. There was some magical flag to add there to be able to see some debugging. And then if you want to debug some NIO stuff, you add some other magical flags to be able to debug them. They decided that that was enough. And now you can just configure the Java util login to log wherever you want, and you will see correct logs. So it makes debugging things in the JDK much more easier. So I'll talk about modules a little bit. It's a really complex thing, so I'll refer you to a book at the end. So it's coming. Before that, I want to talk about 2 or 3 cool features they've added that you might have missed. One is this one. So you're not required to instantiate and type the try with resource anymore, because before that it was required to put the byte input stream into the try. It's not mandatory anymore. You can just pass the variables and it will auto-close. You won't use it as often, but you will. In some cases, I found it really annoying not to have it. So that's fairly useful. The other thing I'll talk about two other things actually. One that I've skipped before. In Java 7, they've added a new reflection API, so it's called method handles. It's meant to replace the old reflection API. It got var handles in Java 9, sorry. So we'll talk about that as well. It's much more complicated, like heavily more complicated, because you can do a lot of really powerful things. If you're the kind of person who's doing reflection a lot, have a look, check other conferences dedicated to that because it's a vast subject. However, you can still use it if you want to do just little tricks. This is an example, so I'm accessing a field and I'm just setting it, and the other underneath I'm having a method and I'm calling it. I won't do the live code because it's too long, so I will just show you the answer to that. So to set a field with method handles, oh, I forgot that. And it's much faster actually because it's different. There's some magic happening again here, but the accessible part is checked when you create the method handle, not when you call it. So with the normal field, when you call the field, every time you do the set, it will make sure it's accessible, and if it is, it will set. So it's pretty slow. This one, when you ask for the lookup is scope in something we call a call site, and then it will remember that, and it will remember if it was allowed to set the field from the place where the lookup was created, and so the method handle will get this superpower, and it won't be ever verified again. So the easiest way is to unreflect the setter of a field. Method are supposed to be methods, but they will magically create setters and getters to access fields as well. So this one is for a field, and then you will just call invoke exact to set the field. The exact is because that's what I said. This thing is complicated. So invoke exact means I want the exact correct type passed to the method. Invoke is a bit more lenient, so it will let you, it will box by itself and unbox, and so it's a bit more flexible. And invoke with argument is, I think, the most flexible one you might get. So it's frequent that invoke exact will fail, and then you will want to use another one. Instead, as you can see, there's a lot of things that are possible, so I won't talk about all these, but do have a look if you're into that. It's the same for method handles. There's a little difference here. So I'm using a public lookup because I can, because the method was public, the field was private. So for so public lookup is giving you a lookup that anybody could use. Like it gives you access to what everybody would have access to. Not talking about modules, because modules will cause an isolation that wasn't there before when you're on the class path. But here, a public lookup is just something that gives you access to whatever was public. The lookup is a bit more powerful. It will give you access to everything. Yes?
Sorry, really quick question. Do method handles enable you to break the encapsulation of record kickstart?
We'll see that later. Okay. Yeah. No. Okay, so that's it. If you don't want to use field or method at all, which normally it's what you want to do, you can just find setters, find getters, find constructor, find virtual. So you have different find. You have find static as well. So all these find will give you the method handle you need, and you will then just call it. So it's not that complicated. Before Java 9, it was a bit funny, because the only way to call a field non-accessible, here all the code is working, but it's because I'm calling a field from my own class. So I'm allowed to do that by reflection. However, if I'm trying to set a field on some other class, it won't work. This will be an example, actually. So if I run that, it will just fail, because it's in some other place. However, so that's the strange part, is that if you do a find setter, it's impossible to do. But if you unreflect a field that you set accessible before, then you get access nicely. It's kind of a strange trick. They noticed that starting with Java 9, and they fixed that. So there's a correct way to do it, which is to do a private lookup in. So you're asking for a private lookup from a lookup, and then you get directly access to whatever you wanted to access that was private. Okay, so that was method handles. In Java 9, let's see here, they've added so we had method handles, but they've added something else. So they've added something called the var handle. I doubt you will ever use it, but I still want to talk about it. Var handle is it's the same thing. It's to set variables all over the place. The main difference is that you can set them in different way. So it's a bit like an atomic. Yeah, it's a bit like using an atomic integer, but directly on a field, and it's by calling something. So you will be able to set volatile, to compare and set, to get an acquire. So to do really parallel processing concurrency things that are a bit more precise using the var handle than what you would do with the normal method handle, getter and setter. So it does exist. You can use them. I think the performance are pretty much the same, but if you're into doing really specific things, you will find everything you need there on setting a field. Like you can set final fields, for instance. You can set different things. Okay. Modules. I forgot modules. Now, modules. I need this here and this here. So the way it works is that before we had everything on the class path, now we don't, or we might not, let's say it like that. IntelliJ will do that pretty efficiently. So if it sees module, it will try to go in the module path. If it doesn't see module, it will stick in the class path. I need a terminal there as well. Okay, so here I have two module app, which is using lib. So far, makes sense. So if I want to use the module path with the Java command, I will use that. So app target, it's a bit different because the class path, in the class path, you reference a jar. In the module path, you reference directories, directories that can contain .classes. So I could put /classes here, or directories that will contain different modules. So here I'm using target because I know that when Maven is compiling, it will put my jar there, and this jar will be seen in the module path. So it's a tiny bit different. So I'm giving the app target, the lib target, and then there's something new as well. So instead of putting a main class, I'm saying, please, your entry point will be this module, so the java9.app module / the class in there. So you give the module and the app. And then, how does that work? Will that work right away? Let me see, just for fun. No, so where are we now? I want to be in Java 9, and then I want that. Okay. And now I need a JDK 11. And then we'll try that. Here we go. I'm still on EA. Oh my God, I need to migrate. Okay, so how does that work? Here we have a package. So pro Tremblay Java 9 lib. So that's my package. I have a hello class here. And I want to expose that to the app because app will use hello. Here we go. So app will use hello. Okay, here I'll comment that out for now. And it will do that's the answer to your question. And so it will do a hello world, which so it just does the hello world on the other one. Okay. So if I want to play that with modules, I will just compile to make sure everything is like I want it to be. Here we go. Here we go. Here we go. Run. Oh no! Don't do that. 2 version of Module Pro app and yes. Okay, it sees the jar and classes, so now it's annoying me. Okay, I'll play cheap, and I'll just kill the one that annoys me. Lib target classes, get out and run that thing. Of course, it's not working because I haven't done any module yet. So now I need to do a module. There's 2 ways to do modules. There's one thing. By default, every jar is a module, and by default, the JVM will look at the name of the file, jar file, and it will say that's the name of the module. It will rip off the version, the normal Maven style versioning we have. It will keep the name, and it will use that as the module name. So this one will be app, for instance. But in general, when you do framework, it's not a good idea. So you will prefer to set some name. So the basic things you can do to support module is at least to reserve a correct automatic module name, because the guessing the name from the file is called an automatic module name. But you can set it, so you can add an entry in the manifest to say, okay, my automatic module name should be Pro Tremblay Java 9 app. So this will So at least this will gives the correct name to your module. So I can do that here. Of course, I can do the same thing here. And now at least I have a rightful name. And if I recompile by doing this, come on, and I delete my unnamed classes, and then I go back to stupid. Okay, we're gone for another turn, and I run that. Hey, you should work now. Why are you unhappy like that? Module Java 9 not found. That's the name of, it's not the name, that's because it's not the name of my thing. Oh, stupid me. Okay. Sorry. Here, because now I have my real name, so it's this. Oh, have you noticed what? No. Okay. Sorry. No. Sorry. Ooh, I'm lost. Okay, let's get back to this one. So this one will use classes. So this one will be nicer to me, and this is the right module path I need. So if I run that again, this should work, but it doesn't because I have deleted my classes. Let me put that again. And yeah, victory. Okay. So this is working, but it's not as nice as it could be because it's not a real module, so everything is exposed. Because auto module will let everything to be available to anyone else, including some internal packages that you might not want to share. And so it's not exactly what you need, but at least it works. So if you want to do it seriously, of course here the goal is to will be to export this package, for instance. So I do this to export it. So I export it, and you can have any amounts. There's a lot of new keywords there in the module info special magic class. I won't go through all of them because I just want to give you a sneak peek of it. So you can export whatever package. It goes by package, it's not by classes. So it's really, you export a package, and of course on the other side of the fence you will require the package to tell, and this can be from anywhere. So what the JVM will do is to check if one of the module is actually exporting that thing, and if it does, then the require will work and everybody's happy. And this will have, as a consequence, it will let you call the hello world on it, which means that if I remove that here and I recompile, here we go. As you can see, the hello class is not available anymore because IntelliJ is now in module path mode. So it's just telling me, hey, you're trying to use hello, but you're not importing it at all, so you're not requiring the package where hello is defined. So I don't want to let you do that. So it all makes sense. So let's put that back, and then we'll go back to the question before. If I want to use a method handle and I want to do a private lookup to do a static setter, because I'm a really nasty person and I would like to change this field here to say something else than hello world, because I want to say hello Henri. Will it work? Who thinks it will work? Are you all wise or you're all sleeping? Of course it doesn't, because I'm trying to do reflection. So even if the package is required, if I try to do reflection on it, it won't like me at all. I need something more that you might have seen. So the trick is to open on top of it. So if I do open, opens mean I'm open for reflection. So use me as you wish. There's a strange thing on that because frequently your project will need to be open for someone else. Like Hibernate, Spring, and all these people doing a lot of reflection. Even EasyMock, we like open packages. So at some point, you have to say it on the other side, because you're not planning to be that open to everyone at first. One solution is, if you're a high-level package, you can be open for Spring, you can open for dedicated other modules. I won't go in details on that, but if you don't do that, you'll get some terrible warning. The funny part is that if you don't use, if you're not using method handles and you're using reflection, it might work. However, that's where the runtime will yell at you with, hey, you're using private package there and private package there and private package there, and you're a bad person. So you'll get tons of warning. It will work, but you get tons of warning at startup. I'll let you experiment that. And of course, if I relaunch this one, it will, no, not that's wrong shortcut. Here, it works perfectly because it's open. Okay. That's all for module. As I said, it's just a sneak peek. So details, please do read a book, watch dedicated conference or whatever. I'll give you a book at the end. Now, Java 10, 2018. It's already dead. It was gone in September, but it's a good thing to know about it. So, and there's not much thing, because as you might have noticed, now it's a 6-month release, so you should not expect tons of things happening between every 6 months, which is the exact purpose. So the way Oracle explains that is that now you'll get some tiny features that it should not be bigger than like Java 8_40 and Java 8_72, let's say. So all these versions, it won't be that more terrible. Between these two Java 8 versions, there was some stuff under the hood that broke a lot of things, actually. So it all makes sense, but there's still new feature in the language that will appear. One of them, so for Java 10, if you're doing desktop application, you have application class data sharing. So there's a more complicated way to share classes. That we used to have that since Java 6, I think. Which means that the JVM will be preloaded in some kind of library, and it could be reused by every Java process, and you can explain which part you would like to expose, and you can even expose part of your application, so of your dependencies, to be reused by others. So if you use, like if you're creating Java command line code, it will make them much faster to start. If you're doing server, you don't care. There's Graal. Graal is now ready for production. Graal is the replacement for Hotspot. It's coded in Java, and it has different performance profiles, so it should be similar, but things are not implemented in Graal. But so some things might be faster, some things might be slower, depending. It's something called intrinsics. Who knows what intrinsics are? 2 persons? Okay. So intrinsics is a magical tricks of the JVM. It will. There's a lot of magic there, so I'm using that word a lot, I know. An example is atomic integer compare and set. If you read the code, you will see a compare and set doing a compare and set, but actually the JVM knows about atomic integer compare and set. And when it sees that code, it just says, hey, I know that one. So it just removes the entire code in there, and it replaces that by one Intel instruction that is super fast. So that's an intrinsics. It's something known by the JVM. There's a lot of these in the JVM, and JVM will notice, hey, you use that, so let me just swap that out, and I will replace it by something I've hard-coded for it that is super fast. And Graal and Hotspot will have different ones. So when you're into like low latency, you're watching out a lot. In most cases, you don't care, actually. So var is there, and then you might wonder, what is var? In Java, we used to have keywords, but we added the enum keyword in Java 5, and it was extremely annoying for everyone having a variable named enum, or everyone having a class called enum as well. So they never did that ever again. In Java 9, they added the underscore because Brian Gertz, in his mind, is preparing to use underscore for something, so he added it here. But he was expecting no one to call their variables underscore, or if they do, they're a bad person. So it doesn't matter if you're harmful for someone who's evil, it's not that terrible. So we just added it. But we kind of stopped adding keywords. So instead, whatever you saw for the modules is called restricted keywords. So there's keyword. So you still can call the variable open, or you can still call the variable module. It's not a problem at all. So if I want here, I can put my int module equal 1, and that works perfectly because module will be reserved only in the scope of the module info.java class. So it's restricted to some in some use cases. We used to have literals, so true, false, null, and string could be one as well, the quoted string. And now we have something new, so a var, which is called a reserved identifier. So it means that you can use it. So if I want to do this, it works. If I even want to do this, it works as well. It doesn't because there's already a var above, but it does, trust me. However, I cannot create a class called var, for instance, because it's a reserved identifier that is used as var. So it just means that when it's on the left side of a definition, it becomes a magical var thing. So this is just Java 10. There was a lot of things written on it because you can use it like crazy everywhere and stop typing. However, in Java, we do love our types and we do like to know what we're doing, and it makes things a bit blurrier. So an example of don't do is something like that. If you do something like that, okay, foo is assigned to a var, that's fine, but then what is var? I don't know. I need to go in foo to see what it is. And if foo is a generic taking parameter, I need to guess the freaking type. And so it makes things really, really, really painful. So don't do that. However, in the case right above, in var1, var1, that's pretty obvious it's an integer because it's an integer there. So it's okay, and it cuts a lot of code actually. A good example would be this. So I have a concurrent map, and I'm assigning it to a concurrent map. So it's pretty obvious it's a concurrent hash map. So do I really need to type all these code? No. I can put the var and be happy. However, as you might have noticed here, it doesn't work anymore because here I'm using a diamond operator. So the compiler is telling me, hey, I found object, because the compiler will decide that the diamond operator is object. So it's like typing object. So it's telling me I cannot assign that to key because it looks like object. So the drawback of that is that you now need to remove your diamond operator on the right side. But it's still a bit smaller. The other thing that is special is that the type changed, because if you notice, before I was using a concurrent map, and now it's not the case anymore because map will be inferred to be a concurrent hash map. So now it's a concurrent hash map. And for instance, if I do this is a method on concurrent hash map. It's not on concurrent map at all. So you're now allowed to use them. In general, you're in your own method and it doesn't matter. We're just used to use like the interface on one side and the concrete class on the other side. But it won't matter much, but just know that you don't have the same type as you used to be when not using var before. Is that clear? No? Good. Otherwise, it's fairly cool to use. I would agree. Okay, yeah. And that's the only real important feature we want in Java 10. But really do watch out. I think I've put the link to there's some kind of help book to when you should use var to be nice with other developers. And that's really important to read because it could get really dangerous at some point. Okay. where am I with the time? I'm even in advance, I think. Surprisingly. Java 11 just went out, so it's brand new, and it's for you to use. If you remember, it's the only currently Oracle build supported version, so that's the one you should actually use if you're using something else. What happened in there? Actually, a lot of cleanup. So they removed tons of things because I'm pretty sure it's because support it forever after, it's a good move. So things like JavaFX went out of there. It's still supported and developed, but it's developed out of the JVM. Corba died, just because I don't think anybody wanted to support it anymore. So I'm wondering some days I'm waking up at night and is anybody been using Corba for the last 5 years or so? I don't think so. Has anybody maybe in this room? Wow, there's one person. It does exist. Poor you. Okay, but there's dynamic class file constants. It's a special things. It's a bit like invoke dynamic. It will allow to add new stuff to the class format without changing the class format. So it's really important for the evolution of Java, but you don't care. Epsilon is a new GC. I don't know why, but we're getting crazy with new GCs. So Epsilon is the one that doesn't garbage collect at all. It's helpful for benchmark, or if you do low latency and you have a lot of memory and you don't want to garbage collect because you don't want to be stopped at all during your day. So you just do that. It really does nothing. It won't garbage anything. So yes, a lot of people find that useful, but but it's really a do-nothing collector. Java XML is gone. This one had an interesting story because it got... so in Java 8 it was there. In Java 9 it became a module, so if you were using it, you needed to add the module to use it. But then in Java 11 it disappeared. So if your framework using it, you kind of need to add a library to it. But then the library, when Java 9 went out, wasn't really ready, the JAXB library. And so now it is, so you can use it. But there was a bit of juggling to have something that works with XML for between 9 and 11. Most of G2E, things like activation, that disappeared. What else? I think transactions. So a lot of the JAVAX things have disappeared. They're somewhere else, but they're not in the JDK anymore. ZGC is another kind of G1 compiler, so it's made for big heaps. It's not the default, but it's there. And Nashorn was deprecated, as I said. And something super cool is called a single file program, and I will show that to you because I love that thing. So the way it goes, where's my terminal? I've lost my terminal. Just let me get it back. Up. So here you can see I have a Java. I will open it here. That will be better. I have a Java 11, the Java class here. And it doesn't do much apart from printing stuff. But the cool thing about it is that it's a Java class. And if I do Java like this, that works. And that's fun. So it's compiled. So the Java takes the Java class, it compiles it, and it executes it. You do not. I don't see in your eyes that you're as amazed as I am, but I think it's like for a newbie starting programming, this is super cool. It removes a lot of stupid stuff you had to learn at first. You can add stuff to the class path if you want. It will work as well. But so it's magically compiling and it's doing this thing. And the really, really cool thing about that, it's this other thing, this other class, this other file here. Here we go. So This is a shell file, so a normal shell file. You can put the hashbang here, targeting your exact JVM you want. You need to specify source 11 for it to work correctly, and then you just code some Java instead of coding some shell. And of course, that does work the same way. Whoa. Ah, now I got you. So, yeah, I'm super happy about that thing. Now I can stop doing bash forever. Yes, save it at the .sh. You do a chmod +X if you want to be executable, and it just works. So the shebang is supported. Of course, it's a single class file, so if you want to code something, it will be in one file, or you have to use another jar in your class path. So you will just add tons of classes if you really need to. But I think it's super fun and super cool. Okay, that's my favorite Java 1 feature. But now about deprecation, if you're a framework, it's complicated because a lot of things were tough to support between 9 and 11, but nobody, not insane, will drop Java 8 because, as you see, you're like 95% of you is using it. So no framework can drop Java 8, but they do want to support Java 11. So to be able to do that, depending on what you're using, I'm a bad person, so I'm a well-known bad person, so I'm using things like unsafe extensively for my frameworks. An example is in unsafe, there was a defined class where you give it an array of bytes and it's just creating a class from there, and it's useful for an instantiation afterwards. But this was in Java 8. It was dropped and replaced because slowly unsafe is disappearing, and it's replaced by real implementation that are not hidden in the JVM. So it's replaced by something in method handles. That's cool, but that's in Java 9. And then the defined class was removed in 11. So I have no real solution apart from doing terrible reflection stuff to be able to support both, and especially to be able to compile. Because on one side, I have what I need, but the replacement is not there yet. And on the other side, the replacement is there, but they dropped the original, so I have no solution. I think we'll see that more and more and more because 12 might drop other things, 13 might drop other things, and we'll still support Java 8 for years and years from now, so it's going to be fun. And especially if you're doing frameworks. Same thing happened, I talked about that a little bit, so the JAXB in 8 is there, in 9 you need to add modules, but then because the module was available in the JVM packaging, but in 11 it just disappears, so now you need to add a JAXB into your module path to make it work. So this you might see it even if you're just an application developer and you want to support different JVM. Okay. I think I'm true. I'm really surprised to be in advance. So you don't even get a break, I think. Yeah, I did everything. But if you have questions, I will be happy to answer them. So yeah, we've seen everything that's new. I hope that was useful. There's a question I ask in general. Who has learned something so I will know what I should retire? Cool, thank you very much. These are different links. So the first one is the one about what's free on the JVM. The other one is adopt a JDK if you want a JDK build. If you want to learn more about lambdas, there's a fact done by Maurice Naftalian, so go for it. Module, the best place to get every keyword at once is the zero turnaround module cheat sheet. You'll get everything you need at least. So read a book, but you get to keep things, to remind stuff you forgot. You'll get everything there. The var style guide is there, so to know how to use var without being annoying for other developers. I'm mentioning it, Heinz Kabutz, the guy who's doing the Java Specialist newsletter, is giving some courses online about all these new features. So you might want to look. So of course it's not free, but it's a good course to learn in depth all the things I just talked about. Great book you should read. So Modern Java in Action. It just went out, so I haven't finished it yet, but the 250 first page are good. So I do hope the next 250 page will be good as well. So this is talking about everything from 8 to 11. Mastering Lambdas is a really good book from Maurice Naftali. He has another one of generics that you could read as well. And Java 9 modularity, so far the best one I've read is the one from Sander Mack and Paul Baker called Java 9 modularity. If everything was fun, this afternoon I'm giving another talk about how to use caching to improve performance. That's kind of what I do for a living. It's a funny talk that you would like, I think. Vote, don't forget to vote. The green button. Yeah, don't bother about the others. These are all the places to reach me. And of course, if you have any questions about anything, or if you want to know anything that we haven't covered, I probably have an example about it. So please just do ask, and I'll detail. Yes. I don't think they. I don't know, but I haven't heard anything about that. I don't think they do exist anymore. Because even Windows is on 64 in modern versions, so that's yeah. I don't know. I think there's no version of them, but I don't know. Yes.
JDK 11. Are you saying that they'll only have new release bug fixes for that for 6 months, or will it be longer? Because that's a long-term.
Yeah, but it's a long-term support in terms of IP support. So it's still a 6 month. Yeah, it's still a 6 month normal support, like free. And in 6 months, if you want to pay for support, you'll get a 3-year normal support. You can pay for extended and whatever you. No. That was the first surprise for me, because I had the same understanding as you, that it was supported for many years, but it's not. For free, it's not. So in 6 months, you're not allowed to use an Oracle JDK in production.
Support fee cost different for Oracle JDK versus
OpenJDK is just free, so there's no support. It's free, but no support. The Oracle JDK, if you use 11 now, in 6 months, you should stop use it, because it gets forbidden. It's not more. It's even more than it's not supported. It's not allowed anymore. Yes. Yeah, you can use it forever after. Exactly. And then I know I don't. So I'm not into. So I haven't looked at that at all. I do know that the pricing has changed as well. So the pricing for getting support is cheaper than before, and they expect more person to go there. But it's absolutely not my job. I'm not involved with that with Oracle. I have no link with Oracle on these kind of topics. So. Yes. Yes, that's one of the things I should have said. You're right. You're absolutely right. Yes, since every vendor will support their own version of the JDK in 6 months, they will diverge. It will normally it's little fixes, so we could expect them to be similar. But yes, they will all manage their own version of source code in their own corner, and result might differ. Yes. 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 Exactly. So that might happen, because so we might decide to backport some fixes we knew happened at Oracle, or Oracle might be nice and give access to some of their fix, and someone will backport it. I know they won't do it by themselves, but we might have access to do it by ourselves. I don't know, or some other vendor might help us on that. It's for now it's a bit blurry, so it's unknown. But yeah, globally, Java 11 will freeze in 6 months. You can consider that for now. It will freeze like any other version, and it will stay like that forever after. Yes.
Question. So the Oracle JDK, is that just 11 and forward that you can't use after 6 months, or is that all?
Everything.
Everything?
Yeah. Yeah. There's a public usage, so like for end users can use it for a little longer, but in production on server side, you're not allowed after 6 months. And both will have. So as I said, Oracle JDK and OpenJDK are identical. So you can just start with OpenJDK and it will get the same features. It should at least. Yes.
So you talked about modules in Java 9, right? So
Yes.
you talked about how to use it, but what is the concept of like what is it? When do we use the module?
Yes. So the idea is all the time. So as soon as you're in Java 9, you should not use the class path anymore. The goal is to have everybody moving to the module path to get a much clearer structure of code usage. It's actually true. It hasn't happened yet for many reasons, because a lot of frameworks are not ready because these things are going really fast. And building Java 9 to be still compatible with Java 8 is slightly annoying, for instance. So all the frameworks are not modularized correctly. And if you have an app, of course you can put a module on your app, but if all the modules underneath are not correctly, of the frameworks you're using are not correctly made yet, you're kind of doomed. So you need to wait for all the frameworks to manage to get there, and then you'll be able to use modules. So it's not, we're not there yet. Especially for reflection and the opens and the things like that. It's the other thing you might expect with module is that you need to use much more command lines arguments, dash dash add open, dash dash add something to make things work correctly. So the goal is to have everybody migrating to the module path, but it's not the case right now. So if you have a new application, you're able to do it. Good for you. But don't struggle. There's no point. Yes.
Earlier on, you were asking how many people are on Java, what different version. Most people are still on Java 8. I'm curious how many people are going to move to Java 11, like say next month, year or
Of course, I don't have the answer to that. I don't know. Frameworks are getting there slowly. Build tools are getting there. So Maven is getting good at it. There's multiple problems because things needs to work on the module path and the class path. Java 9 is the problem actually. It's a really, as soon as you're okay with Java 9, all the others afterwards, it's tiny changes and it doesn't matter much. But jumping to 8 to 9 is the bad part. So that's where it burns a little bit. I could ask who's going to move to Java 11 soon? If you stand the class path, it does work. There's like if you don't have any libraries that hasn't migrated yet, but normally libraries will work as well. Eximoc or Obgenesis, they are not because we're doing nasty things. EHCache is kind of working apart from some XML, but you can add arguments to make it work. However, we use if you use byte sizing to size your cache. To be able to do byte sizing in Java, there's a lot of magic tricks involved there, and these are not working yet, for instance. So EHCache is not totally working with Java 11. That's part of it. That's just an example. We'll be there. Like we're working on it now. So in April, I think it's in April. It should work. So framework will get there. Then some open source framework are managed by big companies like EHCache, like Spring, like Hibernate. So these are happy. Some others, like EasyMuck, Obgenesis, they're done on free time of some guy who now have kids and a wife, so he doesn't have as many free times as before. So these frameworks will be much slower to migrate, and so give them some help if you need. Sometimes it's not that much, and it will be really, really helpful for all these people who created really well-used framework. So it depends on some frameworks. If you stay on the class path, in general, everything works fine. It's using module that is a bit more complicated. But it's a good version to use because there's a lot, as always in Java, there's a lot of performance improvements going on there. And you can also improve your own performance by playing with method handles and things like that. So if you can, just move to Java 11, of course. Yes. When you're an end user doing application, in general, you stick on one version, so you don't really care about, it needs to work on a new version, but you're not juggling with versions. It's different with frameworks because we want to support everything, and yes, it's a kind of a party. Just talk about, is there any question? Otherwise, I have a final magic trick that I forgot to show you, what I said before. So if you're interested, I have a final trick. Yes. Yes, it will end up on slide share. There's two things. So I'm filmed. There's a nice camera here filming me. So that should be on the Oracle Code 1 YouTube channel. And the slides, I will put them on my slide share. And I will probably post that to Twitter. So if you look me out on Twitter, you should find me. What do I want? I want the Java 8. I'll show you another magic trick. No, this is if I find the class correctly. Java 8. That should be this one. Yes. Because I've told you about this, and I forgot to come back to it, and I just remembered. So let's say, instead of doing the for each here, let's say I want to collect. And I want to put that into something. So since the object here is a magical type that we don't know what it is, the compiler has given a value to it. Actually, the only thing I could assign it to is object, but then it's sad again because I cannot print my ID or my name if I wanted to. Hey, completion, please. Ooh, because I'm too low, sorry. Here. Because what I want to do is this, of course. And that's where the var gets interesting, because if I use var, it will start to work. It should at least. What? Sorry? Yeah, of course. Ooh. Yeah. Sorry. Here. So if I assign it to var, it will just decide that it's a list of anonymous inner class that I've just figured out the name because I'm the compiler, and it will let you access these fields from outside of the realm of the Lambda. So that's something really special with var. It can be a type that you will not be able to type by yourself, which is strange, but it does work. So that's the magic trick. There's something that in Java 10 they're also bragging about the fact that you can do this. It's not possible in Java 8.9. In 10 you can var 11. In 11, sorry. In 11 you can add var here. You can type with a var, which you will see say it's absolutely useless. You're right, but I actually had the answer to that problem yesterday during Venkat's presentation. So he told me why it's useful. It could be useful. It's when you want to use annotations. So if you want to annotate your lambda arguments, you will need to use var, because you could use something else. So you could type it normally, but then it's sad because you type it and you didn't want to type it at the first on the first part, and you're forced to use var because the compiler won't accept to give just the name of the argument and the annotation. So you need a type. As soon as you start using like final or annotations, you need a type. So if you see everywhere that in Java 11 var is allowed on lambdas, that's why. And nobody says that. So thanks to Venkat yesterday, I learned that, and then you learn it from me. Okay, that was the goodies for those who stayed. Other questions?
Do you have any thoughts on Jakarta, Jakarta, and also with Oracle's features, how that would work with enterprise containers, Cloudsphere, or your broad question?
What do you mean? So are we talking about modules, or about the fact that G2E and it's living? Okay, I don't know. It seems so. I talked with the G2E guy. They managed to correctly, and there was a lot of legal white tape, red tape in there. So now it's they can do real stuff, and I think if there's support from the community, if people want to use new version of G2E, I think they will go out and they will be as correctly maintained as they used to be by Oracle. So I'm not really afraid. It's still more or less the same people doing it, and they are really good developers. So I'm not that afraid about G2E. However, of course, if adoptions drops and everybody goes to Spring, it might disappear at some point. It was messy for a while. Like things like JAXB, it took a while for it to be cleaned up and be modularized correctly, mainly because they were dealing with all the red tape I talked about, and they had no time to do it, and they had no help from Oracle on that side. Oh no, or a little help. So right now, I do think it will survive. Companies like Tommy Tribe will push on that because they're heavily involved. So I'm not that afraid. It's the same for JavaFX. It went out, but it's still supported by really wise person. So I'm not that afraid that it won't work. On JavaFX, I would be more afraid about the performance part of it, where you need really involved and dedicated engineers to make it work correctly. However, it's already super fast, so I'm not sure we'll need their help that much in the future. So far, I cannot guarantee anything, of course, but so far I'm pretty confident that everything that went out of the JDK will survive and be maintained correctly. Apart from Corba, who will just die. Welcome. Other questions? No, I'll let you go then. Thank you very much for coming.